Okay, welcome back to the next part of the video. Now, in the last video, we brought the XR2 from the point where we had just achieved orbit over to the ISS. Now, before I resume the last video, I'm actually, or rather I should say, before I resume where we left off before, I wanted to go back to the point after just achieving orbit to point out something that was really pretty silly on my part. It was a time warp mistake. I got a little over carried away there with hitting T apparently, and I warped time forward at 100,000 by mistake. So this is the point where I was, I just got up to orbit and circularized, or well, brought my periapsis up to 200 kilometers, and then I was trying to close the distance between myself and the ISS. And this is what I should have did. What I should have done was to just use 1000 X, and you can see that the green line here, that's me. I'm catching up to the ISS, and this is what I expected to happen. But I got a little impatient, and I hit T again, which would take it out to 10,000, and that's actually fine. But I think I double tapped by mistake and shot it all the way out to 100,000. And when I did that, it overtook the ISS and went completely around another half of day. So you'll see here that we're only 12 hours into the mission and we're closing in on the ISS. So this is what I wanted to have happen. I would get to about this point right here, maybe a little farther, and then I would only be 15 hours out, or 15 hours into the mission when I would set up the rendezvous, as opposed to 3 days. So I really thought something was off, and after finishing the video and going back and looking at the scenario, I verified that yes, definitely, it doesn't take 3 days to do that rendezvous, even as far out as we were. So it should only have taken, 15 hours to get to this point, plus a few more orbits to actually finish the rendezvous. So I just wanted to point that out. Just one of those dumb things that happens sometimes when you get careless with time warp. So let's go back to the scenario that we were at prior. Docked at the ISS.
Welcome aboard, Commander. All systems nominal. External cooling online.
Okay, so here we are, 3 days, 19 hours into the mission, and this probably would be more like 19 hours into the mission, if not for that stupid time warp mistake. If I had caught it while I was recording, I probably would have just stopped the video and started over, because it was early enough in that video that it wouldn't have been a big deal to start over. But now I've already completed the rendezvous and docking, so I don't want to go back and do that over again, just for the sake of saving time. And at any rate, we are here at the ISS, and like I said, when I started the mission, we would assume that once we got to the ISS, that we would have access to the resources that we need. So we're not going to say that we only can finish the mission based on the amount of LOX that we carried with us from the start, or based on the amount of main fuel that we carried with us from the start. Mainly on the main fuel, it wouldn't work, because with this configuration of the XR2, remember, this is the configuration that has everything dialed way down, so that it's much more difficult to get where you need to go, just due to the fact that it burns through fuel so much faster. And on that topic, I want to show what we need to do in order to figure out how much fuel we're going to need to get to the moon and land. Now, probably the place to start is going to be to bring up Transx and just start setting up our plan for going out to the moon. So we'll select the moon here, and then we'll press VW, turn maneuver mode on. We'll go forward on this side so we can view the encounter. And now we'll do what we do to get to the moon. We'll add in the necessary amount of prograde. And at this point, I'm just figuring out what I need fuel-wise in order to get to the moon. And there are several components here. Not only do we need to get to the moon, but we need to circularize our orbit when we get there, and we need to do the braking burn so that we can deorbit, and we need to land. So there's quite a few things that we need to add up. Now, we also, since we're going to the moon from the ISS, we're going to have to do an off-plane transfer. So we can't leave the moon, we can't leave for the ISS, you know, like normally. Let's see here, let me reset that. Like normally we would say, okay, now we're just going to go around one time here, and we're going to rendezvous, you know, with the ISS over here at roughly 3 days. But we're not going to be able to do that. We need to rendezvous with the ISS, or we need to rendezvous with the moon over here at this point. So we need to wait until the moon has had time to travel roughly over to this point, and then we'll rendezvous over there. So we're going to have to go around for maybe, let's see, that would be just a couple days. It won't be too long. So we're at 5623. We're going to have to stay docked here at the ISS for a couple of days. So right now I'm just adding in time, and I'm watching, you know, 56323, that's still today. So now we're at 56324, that's tomorrow. 56325, that's 2 days from now. So in 2 days the moon will have gone from there, you know, maybe to here. So we still need it to go a couple more days. So 56325, that's not going to be enough. That's 4 days. So in 4 days it'll go maybe to there. That's still not quite enough. Okay, so that's 5 days. So let's see now what our closest approach is. When we're getting over toward this point. Okay. Okay, we're going to need to go around at least one more orbit, probably 2 or 3 more. Let's go around again. Actually, it looks like we've gone a little too far. I need to go backwards 3 or 4 orbits. It's 1, 2, 3. Yeah, that's actually getting better there. But we're not back far enough, so go around 2 or 3 more. 1, 2. Let's see what that does for us. That's a little closer. You can see the minimum altitude there is 25. So that's still not enough. We need to go back a little bit more. 2, 3. Okay, let's see what that does. It's getting closer. It's not back far enough. And a couple more. So I went forward too far there. I was just trying to eyeball how far forward I needed to go, and I didn't get it quite right. It's pretty close. Looks like we need still 2 or 3 more orbits to really get it in there. One more. And one more, and I think we've got it. Yeah, that'll be fine. So if we leave at this time, 56237, so that's 4 days from now, then we will arrive at the moon, you know, about 3.5 days later. So that's the normal transit time. So for starters, we're going to use the usual amount of delta V for going out to the moon, you know, 3,084. Now what we also want to know is how much delta V, but before I get to that point, let me actually make kind of a note of that number. So we'll start a new, actually we don't really need a new one, we can just put these numbers in over here. We're just going to round that off to 3,100 delta V, or 3,100 meters per second. And now I want to know, when I get to the moon and do the braking burn, how much fuel am I going to use to get myself in orbit around the moon? Let me just do one more thing though. Let me go back one more orbit just to see if it's even better yet. Yeah, actually I like that better. That gives me the option of coming all the way down to the surface. So I like that. Just back off the prograde a tad. Okay, so now on this side what I'm going to do is come over to view setup, and I'm going to use a little trick that Dimitri showed me, because you'll notice we can only go between setup and encounter. But if I come to auto plan and turn auto plan off and change plan encounter to none, now I can bring up view maneuver. And the reason this is handy is because I can now turn maneuver mode on for this stage, and I can calculate how much fuel I'm going to need in order to not only get captured, but I can get a really good estimate on how much fuel I'm going to need to get into a circular orbit. First thing we'll do is we'll go to the date, and we don't want to do the burn now, obviously. we want to do the burn after we arrive at the moon. So we're going to use this date. So we'll go to a medium setting. Now down to fine. And we're already really close, so now let's go to ultra. And hyper. And we're saying we're going to do the burn at about that time, which is really close to the periapsis, the time that we actually get to the lowest approach out at the moon. And it's going to be negative prograde, of course. I'm going to change that to focus. And it's going to be about right there. Let's take a look at that for a second. Yeah, it'll be approximately that. So we're going to round that to, let's just round it to 900 meters per second. So we're going to need 3,100 to go to the moon. We're going to need 900 meters per second to circularize our orbit when we get there. Now, the other thing that we have to figure out is that once we get to the moon and we're circularized around the moon, we're going to need to come to a dead stop and slow ourselves down so we can land. Now, we know that the orbital velocity around the moon is roughly 1,600 meters per second, and this is actually more accurate here to say 1,665, and that's for an orbital altitude of 30 kilometers. So we're going to use this number, 1665. So we need 3,100 meters per second to do the ejection burn. We need 900 meters per second to circularize the orbit when we get there. And then we need 1,665 meters per second to do the braking burn that will actually bring us all the way to a dead stop so that we can land. Now, if we add all those together, we get a sum total down here. Don't know how well that shows up in the video, but it's 5,665 meters per second. Now, this does not take into account mid-course corrections, and it doesn't take into account how much hover that we need to actually complete the landing, because once we come to a dead stop above Brighton Beach, we're then going to be falling, and we're going to have to use some fuel to hover. Now, unfortunately, I don't know how to figure out how much fuel I'm going to use for the actual landing, and I don't know how to know, beyond the shadow of any doubt, how much fuel I'm going to need for mid-course corrections. But the bulk of the fuel that we need, we can figure out, right here. Mid-course corrections are usually relatively small, so, it's not going to be hundreds and hundreds of meters per second. The biggest unknown variable is how much fuel we actually use for the landing procedure. And that's kind of a big question mark. I'm not sure. But at the very least, we know that we need, 5,665 meters per second of delta V. Now, if we remember from part 1, the XR2 in this configuration only had like 2,700 meters per second with the main tank. So we know that we're going to have to at least bring one extra fuel tank with us, one extra payload fuel tank. And we may also need to get rid of the Scram tank and replace that with the main engine tank. So let's find out. So we're going to now open our supply lines and just top off our resources. So let's do that.
Locks hatch open.
We don't quite have enough locks
Locks resupply
left over
system
to get to the moon,
online.
just due to that time acceleration mistake on my part. Otherwise, we would have enough locks to go to the moon, and we wouldn't even have to resupply the locks here. But again, like I said in the start of the video, we're making the assumption that we have all the resources that we need
Fuel hatch
here at the ISS.
Refueling systems online.
So we're just going to top off everything
No external line pressure.
except for Scram. I didn't even mean to do that. Okay, I'm going to put in a little bit of 10x to speed this up. Okay, APU's full, RCS is full, and we're almost full on the oxygen. We've actually got enough, but I'll just top it off.
NOx tanks full. Main fuel tanks full. Refuel locks resupply
Okay.
systems offline.
Now we're all filled up. So let's bring up burn time calculator. And we're probably, we're going to have to undock here, unfortunately, because there's no way to tell burn time calculator to not include the mass of the ISS. So let's turn off external cooling,
Using onboard O2.
and we're going to undock just for a moment.
Undocking confirmed.
Undocking confirmed.
And I'm going to zero out the velocity difference so I can stay right here by the ISS, because I'm going to redock in a moment. Now, according to burn time calculator, we have 3,165 meters per second worth of delta V, but that does not include the fuel from the main tank. Or, excuse me, it doesn't include the fuel from the external tank, because burn time calculator doesn't include that extra fuel. So if we come up here to the payload editor and look at this tank, we can see that it has a total mass of 3,705.20 kilograms. So let me put that number into a calculator. 3705.2. And we need to subtract the weight of the container itself. And if I bring up the payload editor,
1.
it tells us here that the weight of the container itself is 355.2. So I need to subtract 355.2. And this is the weight of just the fuel itself. That's what I need to know. It's 3350. So I'm going to put that into the extra fuel mass, 3350. And now I've got an estimate total delta V of 5,066 meters per second. And if I want to add in my RCS as well, then I can add in 804. Well, it's actually 803.5. So let me put that number in instead. 4153.5. And I've got a total delta V of 5,563 meters per second. And remember, we need 5,665 meters per second. So we're still a little bit shy of the total amount of delta V that we need. And remember that that calculation here does not include mid-course corrections, nor does it include the amount of fuel that we need when we're going to hover down go ahead and redock.
Contact.
Nor does it include the amount of fuel that we're going to need when we hover down, to actually land. So we now know that the main fuel tank plus one external tank is not enough to complete the mission. So we need to replace the scram tank with main fuel. So we'll come up here to the payload editor, and we'll look here at the scram. And what we're going to do is we're just going to say that we're going to take the scram tank and give it to the ISS. Unfortunately, I don't really have a way to simulate that with the robotics arm. I would actually really like to do that. I wish I could, but to have a robotics arm take the scram tank out and put in a new main fuel tank, but I don't have the setup for that. So we're just going to have to use the scenario editor, not the scenario editor, but the payload editor for that. So we're going to get rid of the scram fuel tank.
Warning, scram fuel depleted.
We just gave that to the ISS, and now we're taking away a new main fuel module from the ISS. So now we've got two main fuels in our cargo bay. Now, if we go back to our calculator, and we take this number times 2, because now we have 2 fuel modules, so we have 6,700 extra extra main fuel, and we can put that in here. Of course, now I've got to undock. I guess I should have left myself to undock for another second.
Undocking confirmed.
Undocking confirmed.
Just zeroing out the velocity difference so I don't drift really far away. But now we've got 6,525 meters per second. And if we want to add in our RCS, then we can say plus 802.6. And now we can put that number here, 7502.6. So we have a grand total of 7,033 meters per second of delta V to get out to the moon and complete our mission. And I'm certain that that will be enough, because that will give us over 1,500 meters per second for mid-course corrections and for the hover process to land on the landing pad. So let's move forward and redock. Now that we know we've got everything that we need.
Houston, we show capture and hard dock. Congratulations.
I just wanted to go through that whole process there, showing how to calculate the fuel, because using this vessel with this configuration, you can't take it for granted that you've got the fuel that you need. Normally, when you use the default XR2 in its default configuration, you can just fill up the main tank and you don't even have to give any consideration to fuel. You've got enough to get to the moon, you can come back, you can go to the ISS, you can even go to Mars. So you don't even have to think about fuel. But it's kind of cool to use this configuration because it forces you to really do a bit of fuel planning, which I think is actually kind of fun. So I'm going to leave the video here at this point, and we'll call this just the fuel planning process. Now that we've got all that figured out, we'll come back in the next part and we'll time warp over to the point where we can actually do, where we can actually undock from the ISS and head out to the moon, and then we'll finish that part of the journey. So if you like this part of the video, let me know by leaving a comment down below. And if you have any questions about all this fuel management stuff, leave your questions down below and I'll certainly respond to them. That's going to be it, and I will see you in the next video. Actually, let me Control S to save. Okay. Mistake, and shot it all the way out to 100,000. And when I did that, it overtook the ISS and went completely around another half of day. So you'll see here that we're only 12 hours into the mission and we're closing in on the ISS. So this is what I wanted to have happen. I would get to about this point right here, maybe a little farther, and then I would only be 15 hours out, or 15 hours into the mission when I would set up the rendezvous, as opposed to 3 days. So I really thought something was off, and after finishing the video. Okay, welcome back to the next part of the video. Now, in the last video, we brought the XR2 from the point where we had just achieved orbit over to the ISS. Now, before I resume the last video, I should say, before I resume where we left off before, I wanted to go back to the point after just achieving orbit to point out something that was really pretty silly on my part. It was a time warp mistake. I got a little over carried away there with hitting T apparently, and I warped time forward at 100,000 by mistake. So this is the point where I was, I just got up to orbit and circularized, brought my periapsis up to 200 kilometers, and then I was trying to close the distance between myself and the ISS. And this is what I should have done was to just use 1000 X, and you can see that the green line here, that's me. I'm catching up to the ISS, and this is what I expected to happen. But I got a little impatient and I hit T again, which would take it out to 10,000, and that's actually fine. But I think I double tapped by mistake.
Welcome aboard, Commander. All systems nominal. External cooling online.
Okay, so here we are, 3 days, 19 hours into the mission, and this probably would be more like 19 hours into the mission, if not for that stupid time warp mistake. If I had caught it while I was recording, I probably would have just stopped the video and started over, because it was early enough in that video that it wouldn't have been a big deal to start over. But now I've already completed the rendezvous and docking, so I don't want to go back and do that over again, just for the sake of saving time. And at any rate, in going back and looking at the scenario, I verified that yes, definitely, it doesn't take 3 days to do that rendezvous, even as far out as we were. So it should only have taken, 15 hours to get to this point, plus a few more orbits to actually finish the rendezvous. So I just wanted to point that out. Just one of those dumb things that happens sometimes when you get careless with time warp. So let's go back to the scenario that we were at prior. Docked at the ISS.